We're now going to talk about conditional probability. So conditional probability is very different than basic probability in that conditional means you are given a specific condition in which to calculate the probability. The key words that you will notice here are if or given. Generally, these are the two words that you're going to see. So if it says, if a person wears glasses, whatever follows the words if or given, that's the group you're interested in. So we are no longer interested in the entire group. We are interested in just the subset that follows the if or given. So let's do some of these. We have math majors and business majors, and we have green-eyed people and blue-eyed people. So if a math major is chosen, what is the probability they have blue eyes? Now, if we think through this, it says if a math major. That means math majors are the only ones we care about. This is the line. If a math major. So that means our total is 90, because if a math major, there's 90 total math majors. Then it says, what is probability they have blue eyes? So again, only looking at the line that I highlighted in purple, there are 70 blue eyes. So it's 70 over 90, which gives us 7/9. And that is the probability there. Okay, so now let's go to the next one. If, first let me get rid of this up here. Okay, so if a blue-eyed person is chosen, if blue, that means we only care about blue-eyed people. So that means there is 100 of them that have blue eyes. What is the probability they are a math major? Well, math majors on top, and I would have 70 over 100, which gives us 7 over 10. Okay. Letter C, what's the probability a blue-eyed math major is chosen? Okay, so what is the probability a blue-eyed math major? Well, blue-eyed math major is here. It doesn't use if, given. It doesn't give me a specific area. So we're talking out of the total. What is probability a blue-eyed math major? So that's 70 over 150, which is 7/15. So again, wording matters. Sometimes you got to say it 2 or 3 times out loud just to make sure you are hearing things and understanding. Let's go to letter D. What is the probability a business major is chosen if they have green eyes? If they have green eyes, that means we only care about green-eyed people, that's 50, and we want a business major. So that's 30 over 50 or 3/5. So the if doesn't have to be at the front. It can also be in the middle. So you got to really pay attention to the wording. Let's do a couple of more. So now we're going to talk about types of people, whether they jumped or whether they fell, and whether or not they were wearing a blue shirt, green pants, or brown shoes. First step, we're going to go ahead and complete the table. And when we find the probabilities, we're going to round them to 3 decimal places. So as I add across the top, 35 plus 27 plus 63 gives me 125 of those who jumped. The next one we've got 59, 54, and 25 gives me 138 folks who fell. And then we have 94 wearing a blue shirt, 81 wearing green pants, and 88 wearing brown shoes. Now, I would recommend that you pause the video, try to answer B through G, and then come back and watch this. So, all right, let's do this one at a time. Letter B, I'm going to put this back up just so that it's not as confusing going through this. What's the probability someone with a blue shirt was chosen? Probability someone with a blue shirt. Well, that's pretty straightforward. That's just blue shirt over total, because blue shirt, lost my pen, blue shirt over total. So there were 94 blue shirts over 263. And rounded to 3 decimal places, I'm at 0.357, or a 35.7% chance that we would choose someone who's wearing a blue shirt. Great, letter C. What's the probability someone is wearing green pants or fell down? green pants or fell down. So, well, 81 people wore green pants. 138 people fell down, but that means I counted green pants fell down twice. So minus 54. So that will give me a numerator of 165, and that goes over our total because we're just finding someone. We don't care who. And as we round to decimal place, we'll get 0.627. You also could have just counted 59 plus 27 plus 54 plus 25. That would have also given you 165. So it just depends on what you feel most comfortable with when you're calculating the or statements. Okay. Let's move on to letter D. What is the probability someone jumped in brown shoes? Jumped in brown shoes. What is the probability someone jumped in brown shoes? So that would be 63 over 263. Because again, there's no conditional here. This is just people jumping in brown shoes. So that's an and statement. So 0.240. Now we can say if the person was in a blue shirt, that means we only care about blue shirts. That means our total is 94 because there's 94 total blue shirts. What's the probability they fell? Well, that would be 59. So 59 out of 94 gives me a decimal of 0.628. Let's do another. If the person jumped, okay, so if they jumped, that means we're looking at this first row only. So we know 125 people jumped. What is probability they were in green pants? Well, 27 of them had green pants on. So 27 over 125 gives us 0.216. And then last but not least, letter G, if the person was in green pants. Okay, so that means we have a denominator of 81. What is the probability they jumped? 27. So that gives us 0.333. You'll notice, I want to just point out real quickly here before we finish this one up, F and G are just kind of the opposites of each other. In F, if they jumped, probability in green pants. And then letter G, if they're in green pants, probability they jumped. Notice that the numerator for both of these is 27, but it's the denominators that change. Because when we're talking about these, when you follow the word if or the word given, that tells you the category that you're focused on, right? So in letter F, if the person jumped, that gives us the total of 125. Okay, so that gives you your denominator. Whatever follows if or the word given gives you your denominator. All right, so that's playing with conditional, playing with tables, and really understanding and playing with the words, right? You have to really focus on the wording of the question.